Welcome to this video in our series, A Beginner's Guide to the C Programming Language. Our last video discussed the different operators in C and how to use these operators to perform various operations to process data. In this video, we will see how a C program is structured. We will discuss two kinds of functions, the main function, which is the entry and exit point of the program execution, and user-defined functions. The third kind of function is a library function provided in the standard C library. We shall work with these functions in another video. A later part of this video shall include a live demonstration of how to write and call user-defined functions. So before we start, please follow us, share and like this video, and subscribe to get notifications of new videos in our channel. Now, every programming language has a well-defined structure. A program in basic language consists of a set of statements. A C program consists of a set of functions. A function is a block of code that receives arguments, executes a set of statements to process them, and returns a final result to the caller. A function can be called from anywhere in a program. Let's start with the basic organization of a C program. As seen in our previous videos, every IDE requires an application to have a well-defined structure. In the IDE we are using, we need to create a solution. A solution contains many projects. This happens when your application is large and you may have many developers developing code simultaneously. Each project in the solution will contain many source files. Typically, you will break large code into different source files, where each source file contains code that manages a certain functionality. Each of these source files will have an extension .c. For example, if you are developing a large inventory application, then you may have multiple source files, and each source file would have the code for a module in the application, like itemmaster.c or purchase module.c or order module.c. This breakup of source files makes it easy for you to organize your program and find code that you wish to work on. Within a source file, a C program will have statements. There are three kinds of objects that you can have in a source file. The first are compiler directives that are instructions to the compiler, and they are executed during compile time. We will discuss compiler directives in our next video. Then we have declarative statements that are used to declare global functions and variables. And finally, you will have function definitions that are implementations of user-defined functions. A function is a block of code that contains different kinds of program statements. Within it, you can use a declarative statement to declare local variables, expression statements to perform operations and function calls, and branch and iterative control statements to execute code blocks conditionally. Now, when you write code and come across a set of statements that need to be called multiple times in your code, you should move that set of statements in a function. Ideally, a function should perform a single well-defined task. It should not do multiple things, since it would reduce the reusability of the function. In addition, a function should be self-contained. That is, any data it needs to perform its operations should be performed and defined in the parameter list. A well-defined C program will contain a hierarchy of functionally well-defined functions. A function can be reused by calling it, passing to it the data it requires to process. The function returns a result that the calling function can then use. A function can also call other functions. A function can also call itself, and we will discuss these scenarios later on in the video. Overall, we break functions into three types. The first is the function main. The main function is the entry and exit point of a C program. Every C program starts execution with the first statement of the function main and exits after the function main returns. A C program can have one and only one main function across all source files. The second type of function is a user-defined function. These user-defined functions are created as reusable units of code that perform a well-defined functionality which is decoupled from the rest of your code. This decoupling promotes reusability. The third type of function is a library function. The standard C library contains many functions that perform various general purpose functions that can be reused, like math, standard input output functions, operating system calls, etc. In addition, many software component providers perform libraries that can provide specific functionality, like statistical libraries, graphical, and other utility functions. So, library functions basically are of two kinds. They are library functions provided by the C standard library, as well as other libraries that are provided by software vendors. Now, when a C program is compiled, the compiler inserts a startup routine. This startup routine initializes some areas of memory, collects the arguments supplied by the user in the command line, and passes control to the main function along with the command line arguments. After the function main completes execution, it returns to the startup routine, which releases memory, cleaning up if required, and returns to the operating system. As can be seen here, the function main has two parameters. The first parameter is the number of arguments in the command line, and the second is the list of arguments. We will discuss this in a later video. Now, user-defined functions have three components: the function declaration, the function definition, and finally the function call. The function declaration is also called the function prototype or the function signature. It declares the return value, name, and parameter list in parentheses. Note that the function need not have a parameter list. In this case, the parameter list is specified as void. Also, a function may not return a return value, in which case it is also declared as void. The function declaration declares the function's signature to the compiler, which is used when compiling code. The function definition is the function's body, which contains the statements that perform the function's process. It consists of the function's signature followed by a body of code. Note the return statement, which returns both control and a single value to the calling function. Once the function is declared and defined, it can then be used by making a function call. A function call is done in an expression. It results in the function being called. After the call is done, it returns to the following statement after the call. Now, what happens when a function is called? When the program execution encounters a function call, the parameters defined in the parameter list are created on the stack. Then each argument value is copied to the newly created parameters. The return address of the following statement after the function call is then pushed to the stack. Then the execution control is transferred to the first statement in the called function's body. Execution then proceeds within the function till it reaches the end of the function. After the function fully executes, the return value is copied back to the function call. The parameters are destroyed by unwinding the stack, and control is then returned to the return address stored in the stack before the function call. A function can call other functions. This creates a hierarchy of function calls within the application. Each function is like a reusable component that performs a known functionality. A special kind of function is a recursive function. This type of function calls itself. Usually, recursive functions are discouraged because they are difficult to understand and maintain. However, in some cases, they make the program smaller and more intuitive. We have shown a simple example of a recursive function call. Here, the function factorial is called in the function main. The purpose of the call is to find the factorial of 4. This is passed as an argument to the function. As seen in the table on the right, each recursive call is nested in the previous call to the function. This happens till the parameter num is equal to 1. You can see how the recursion unwinds in each return statement until it returns from the first call to factorial, where it returns to the function main with the final result. We have reached the end of our discussion on a structure of a C program and different kinds of functions and function calls. Let's have a look at how it works in practice. Here we have declared a function sum, and as you can see, the function signature specifies that it returns an int return value and takes three int arguments. The function is called in line 8. It passes three arguments which are constant values 5, 10, and 15. The function definition then adds the three parameters and returns the sum to the function. Let's single step and see how this works. The function main declares an int variable sum val, which is initialized and has an arbitrary value. The current execution line is at the function call to the function sum. Press F11 to step into the function sum. As can be seen here, the function main variables are no longer visible in the function sum. This is because they are local to the function main and are not visible outside it. We have declared variables in the parameter list, which are now created and initialized to the values passed to it. A new local variable is also created on the stack and it is uninitialized. The following statement adds all three parameters and the result is stored in the local variable. This value is then returned to the main function. The return value is assigned to the variable that stores the return value of the function called to sum. Now let's have a look at how a recursive function is written and executed. In this program, we have declared a function called factorial that will calculate the factorial of a number passed to it as a parameter. The function is called recursively, decrementing the parameter value until it reaches 1. I have explained the function behavior in the earlier part of this video, so let's single step and see how this function executes. The first time the function factorial is called is from the function main, where it is passed the value 4. The parameter num is not equal to 1, so the control flows to the next statement, which calls factorial once again after decrementing num. Thus, num is now 3 in the new call to factorial. This repeats twice. The call stack shows the 4 calls made to the function factorial. The bottommost call to factorial is from main. The top 3 are from the function factorial itself. In the last call to the function factorial, it is called with a parameter of 1. The function then just returns with a return value of 1. The recursion stops out here. You can see the recursive call unwinding until it completes the operation and returns back to the original caller in function main. The return value is shown here as 24, which is the correct value of the factorial of 4. This is the end of this video. Thanks for joining us over here. Please like and share this video and follow our channel for more of a beginner's guide to the C programming language. The next time we will look at compiler directives in C. Till then, goodbye.